with that, session number 4, security and privacy. Very happy to have Steve Bellovin. Are you there, Steve? Are you coming on? There he is. The Percy K. and Vida L.W. Hudson Professor of Computer Science at Columbia University, and J.R. Rao, IBM Fellow and CTO for Security Research at IBM Research. And over to the two of you.
Thank you very much for that introduction, Sharon. And hi there, Steve. Looking forward to hosting the session together with you. We had prepared a few charts. Let me just go and bring them up, and hopefully you'll be able to see these charts. And Sharon, does this come through?
Yes, you're good.
Okay, perfect. So what Steve and I had planned for today was to talk about what the security industry is really abuzz about. And that has been a very recent development, in fact, dating to May 12th, when the White House actually issued an executive order on improving the nation's cybersecurity. So in the space of the 30 minutes that we have, we wanted to very quickly give you an overview of some of the sections that the order actually covers. And then we really wanted to go down pick a couple of these areas which we have been working on, which we're very passionate about. Steve would lead a discussion around some of the cyber safety review boards. And I wanted to talk a little bit about the software supply chain issue, which has been plaguing us for a while. So without further ado, Steve, do you want to say something, or should we dive right in?
Just dive right in.
Okay. Okay, so just to give you a very quick overview of what the executive order is about. The executive order itself is about, it hit the street about, I would say about 5 weeks ago on May 12th. It was long anticipated, especially in view of the sorts of cyber incidents that we've been witness to. I think the most recent ones that most people are familiar with are the SolarWinds attack, as well as the ransomware attacks, notably on the Colonial Pipeline. And the effort behind the executive order was to really recalibrate and change our approach to cybersecurity. And the way this actually works is to really start with how the government is approaching cybersecurity, not just in terms of how it is procuring services, IT services, and how those are protected, but also the sorts of best practices and standards that they would mandate for federal procurement services, as well as how they would really change the way that security is practiced across the industry. So let me just touch upon a few of the sections that the executive order actually covered. The first one was really around policy, and really it sets the tone for how the government is going to approach cybersecurity. It looks at it as a public-private partnership, which it always has been and must continue to do so. And it really calls out the fact that whether the systems that we're talking about are cloud-based or on-premise or hybrid, and be they federal systems or otherwise, that they must aspire and in many cases exceed the standards and requirements for cybersecurity that are actually put forth in this particular order. The second section, really around removing barriers to sharing threat intelligence, really tries to address a problem that has plaguing us for a while. When the government procures services, whether they are cloud service providers or they are from the procurements of products, quite often the vendors might have information regarding the different threats or vulnerabilities or even incidents that happen in those environments, but they may, for some reason, may be precluded from sharing that information with the affected customers, or in this case, the government. So this area really seeks to knock down some of the barriers to threat intelligence sharing. The third section around modernizing federal government for cybersecurity really builds on an idea that has been in works for almost like a decade now. It builds on this concept called zero trust architectures. For a while, we know that perimeters that we have relied upon to protect enterprises have been porous, and that we've seen attacks, be they in the form of technology, services, or even people, cross those perimeters quite easily. And so in many ways, the sharks are in the water. And this idea of zero trust architecture, which goes back more than a decade, I mean, that's when we in IBM started looking at it. And there was something called the Jericho Forum that said, listen, we need to have a different approach to security where each resource or each service needs to protect itself and not trust its environment. And then I think Google picked this up, and Google had a couple of initiatives in this space called Beyond Prod and Beyond Core. And later on, I think some of the analyst community, Forrester and Gartner, picked it up. And now it's something that's part of this executive order. The fourth area we'll talk a little bit about later regarding the supply chain. and the fifth area, around the Cyber Safety Review Board, very much trying to bring something similar to the National Transportation Safety Board to the area of cyber is something that Steve will lead a discussion on. The sixth area is around response. So till now, if you look at the security industry, we've had a number of technologies that have looked at detection, but very few that have really ventured into the space of planning and both remediation and response and recovery actions, quite often because this is very specific to a particular customer or a particular deployment. And so where the federal government wants to raise the bar is in trying to come up with playbooks that would, maybe a little bit generic playbooks that might actually set the stage for how one would respond to cyber incidents and not scramble at the time that they actually happen. The next area is around improving the detection of cybersecurity vulnerabilities and incidents. This is, in the security space, we know there are two entry points for attacks. One is, of course, people, which is the human in the loop who might be making mistakes or errors, and as a consequence may raise the risk. And the other is the endpoints, because they are distributed and they are custom to the user who's using them, and they're very hard to secure. And so the government is mandating to deploy endpoint detection and response initiative, which will very proactively protect the endpoints that are deployed for government purpose. Then the next couple of ones, I'm not going to spend a lot more time on. They are around remediation and response and around increasing the level of security for national security systems and providing exceptions as the case might be. So this is with very broad brushstrokes, something that has, that came down, as I said, about 5 weeks ago. But in the 2 decades that I have been working in security, this has been about as disruptive and as consequential an order that has come down. And it is our hope and expectation that in light of recent security breaches and incidents, that this is really going to lead to some changes in the way that security is practiced across the industry. So what we're going to do now is we're going to pivot a little bit and pick up 2 of these topics. We'll start with the Cybersecurity Safety Review Board work. And let me turn this over to Steve. This is an area Steve has spent a fair bit of time working and thinking about. And over to you, Steve.
Thanks. So, most of us, I imagine, are, at least in non-pandemic times, are pretty frequent flyers. And airplanes don't crash. Commercial airlines, for the most part, especially in countries like the US, don't crash anymore. It's extremely, extremely rare. Aviation is amazingly safe. And the question then is why? And, if you go back 50, 60, 70 years, that was not the case. The reason why aviation is so safe is that aircraft manufacturers, airline operators, regulators have learned from previous incidents what went wrong and how to prevent it. And right now we're in the lots of crashes phase of computer networks. And one possible answer is, let's learn what went wrong and also what has worked. And so President Biden's order calling for a cybersecurity safety review board modeled on the NTSB is a very good start. It's something I've been advocating for about 10 years, working more recently with Adam Shostak and Rob Kanaki on the topic, the workshop papers, and so on. And this is a good, the executive order is a good start, but it doesn't go quite far enough. The order said, investigate significant incidents, that's fine. Federal, civilian federal, or in some cases, non-government computers, probably critical infrastructure, that's fine. The board will include government and private sector individuals, good. But convened on demand is not so good. This is too big a problem to have ad hoc, very part-time people working on this. And so it's good that one of the charges to the board is its first report should assess its composition, mission, scope, and authorities and sources of information. But the worst problem is that the charter of the board right now is just report to the Secretary of Homeland Security on how to improve security and response. And what we think is necessary instead are published reports like the NTSB puts out for airline and other major transportation incidents. It's why aviation is so safe. I don't know if any of you have ever read an airplane crash investigation report. It's amazingly detailed. They look at everything. They find all the little details. And this is used to guide others. The tone of these reports is very important. The NTSB is not composed of prosecutors. If there's a crime, that's the FBI's job. They don't work, in the cyber world, they wouldn't worry about reverse engineering malware. That's, the intelligence community might want to do that. But what they need to know here is, here's how it got in, here's how it spread, not exactly how it operates. Say just the facts and the straightforward conclusions. NTSB reports cannot be used for disciplinary activity or for civil lawsuits. It's not a finger pointing exercise. It's what went wrong so we can learn from it and how to fix it. It's to find the root cause of the problem, not just how to recover. And it's not, we're dealing with complex systems. Software is complex. There was a weak password. Why was there a weak password? Why wasn't there two-factor authentication? Why wasn't there the budget, if that was the issue, for deploying two-factor authentication? Why was it rejected perhaps on usability grounds or software compatibility grounds? What were all of the factors that went into it? You don't stop with the simplistic answer, somebody had a weak password. There are many things that go into the failure of a system. Just to give one simple example, the initial penetration of a system is typically a chain of exploits, and then the attackers are moving laterally within an organization to get at the resources they really want. Why weren't they detected internally? Why wasn't there enough internal segmentation and more? And why wasn't exfiltration detected? And more and more and more like this. What are the root causes of the problem? It's a complex system. As I've often remarked, complex systems fail in complex ways. You can't rely on a simplistic answer. So you need a full-time staff, not a part-time board. You've got to build up the skills, the background and experience to say, okay, I've seen this one before. I know where this one is going. You're not just responding to incidents any more than the NTSB just responds to incidents. The NTSB is also charged with putting out reports saying, hey, we've seen this as a pattern in incidents. Let's look at that as a cause. And we would like to, Adam Shostak and I would like to go further. In aviation and some other fields, there's a voluntary near-miss reporting system. Let's have the same thing for cyber incidents, where you were almost penetrated, some second or third line defense worked, and you were able to stop it from becoming really serious. I don't mean somebody poked at my firewall looking for an open SSH port. I mean, they got in, but the internal intrusion detection system caught them and were able to shut down the domain controller, something like that. Find out so people can learn what ultimately worked. This is voluntary. It's difficult because you want to preserve privacy. You want to avoid liability to companies for discussing this. One of these references here is to a law review article with lots of legalistic discussions. But again, we need, I'm fond of quoting Mad Magazine, Alfred E. Newman. Learn from the mistakes of others. You'll never live long enough to make them all yourself. That's what we need in the cyber world. What can you learn? And that's what a CSRB can teach us, how to learn as an industry, as a profession, what actually works and what doesn't, and what the real weaknesses and real strengths are. Darren?
Thank you, Steve. I mean, that's very illuminating. I do have a question in my mind, which some of our audience might have as well. Given that cyber breaches very often are caused by malicious acts or malicious actors, is there a fear that by publishing details and forensics of an incident, given that similar vulnerabilities that might have been exploited may be occurring elsewhere, we might be empowering the attackers by giving them this information?
The attackers generally know what has worked. There was a quote I'm fond of about locks. The strength of locks, and teaching lock picking is empowering thieves and so on. And the thieves already know how to pick locks and know what the problems are. And what I love is that this was published in 1853. The attackers know. If you want to go report specific vulnerabilities to the vendors first, I have no problem with this. But ultimately, it's not just going to be here's a buffer overflow in this component. Here's a use after free. Let's fix that, sure, but it's all the things put together that led to the penetration. I want to get at the root causes.
It absolutely makes sense, and sharing of information empowers us more, and including responsible disclosure policies, working with vendors would definitely increase the security posture of many of our systems. So I hope that that the executive order would really help us make advances on the Cyber Safety Review Board effort. So that I don't know if there are any other questions regarding the Cyber Safety Review Board, but in the interest of time, let me just move forward a little bit here. I did promise that we would talk about one other area, and this has to do with the software supply chain security. Now, when we look at how software is being built today, and increasingly there is a reliance upon open source and open source components. And if you look at how developers are assembling large systems, it's very rare that they write a completely new code. Very often that they're able to pull libraries or modules from other sources, and they really build software on top of this. Now, this is a little bit scary from a security perspective, because on the one hand, we know from statistics reported in the literature that on the average, enterprise downloads almost 430,000 times. It downloads for example, open source components and modules. And we also know about 11% of these modules, this has been reported in market literature, are vulnerable. And we also know that year over year, there has been something like a 400% increase, 430% increase in the attacks on open source software. Now, given that we are relying increasingly upon open source, that we are relying on a supply chain for software where the provenance or the dependencies of that software are very, very often not explicated. This sort of begs the question as to how can we actually start looking at and assuring ourselves about the security of the software supply chain. Now, I think in terms of the Section 4 of the executive order really talks about enhancing software supply chain, and it actually identifies NIST as one of the federal agencies entrusted with the task of bringing forward an actionable plan and recommendations. So what has happened since the order issued is that on June 2nd and 3rd, the National Institute of Standards actually convened a workshop, a two-day workshop on enhancing software supply chain. It was attended by, attended by more than 1,400 participants across the industry. And NIST actually invited a two-page position paper from different vendors on how they should approach this space. And again, in the spirit of transparency, and NIST is to be applauded in this space, and there's a link at the bottom of my charts, where NIST has made available almost 150 different position papers from different vendors as to how we should approach the space of software supply chain. Now, just to summarize, I think it's not that we have done a poor job in security. I mean, we've been constantly working, chipping away at security. It's not that we are falling short as much as it is that this security is the proverbial arms race, and that the stakes are getting higher and higher. And as we change the ways that we actually develop and build systems, and we change the way we source our software and systems, adversaries get a better foothold and are able to infuse vulnerabilities into the system. So NIST actually convened 4 different panels as part of their workshop. And the approach they take is the first one is around designating what is considered to be critical software. Now, of course, if we start with the presumption that everything is critical, is not really going to help us, because if everything is critical, really nothing is critical. And so in a way of trying to make the problem more tractable, one aspect, one conclusion from the workshop was that we want to limit the scope of what we consider to be critical software. A second panel looked at the standards, practices, and conformance around secure software development. And NIST already, in fact, has a secure software development framework. There are other industry-led frameworks like Safe Code, for example. Of course, Microsoft, even vendors have their own efforts, like Microsoft's SDLC, Software Development Lifecycle. Within IBM, we have our security engineering efforts. And so one of the thoughts that came out in the discussion was that we need to be able to build upon many of these frameworks and really take it to the next level, so that we don't lose sight of the standards and best practices that we have already developed. A third panel, which personally was very interesting for me, was around really where we go with tools and techniques for testing software. And here, we've seen there's a plethora of tools that range everything from static analysis to dynamic analysis to gray box analysis. There is looking at binaries, looking at source code. But really, the 2 techniques that have come forward, as has been exemplified even in DARPA's Cyber Grand Challenge, have been things like fuzzing, and fuzzing comes with various flavors, as well as symbolic execution. And those were 2 techniques that have proved to be valuable. And I think as we go forward, we would try to build on some of these capabilities to secure the supply chain. And then finally, there are the security measures of how often organizations or vendors should actually be conducting cyber hygiene exercises across critical software, and how the consumers should really have a risk-based approach. Because even if a software is bug-free, depending upon how it is deployed, how it is configured, and how it is used, those could introduce a lot of vulnerabilities into the process. So this is a chain, this is an area, a section where we expect to see a fair bit of activity going forward. In fact, if you look at the executive order, it is very prescriptive. It kind of lays out actions that the federal government has to take or agencies have to take in 30, 60, 90, 180, and 360 days of the issuance of the order. So, and so we are looking forward to trying to use many of the advanced techniques, for example, like AI-based techniques to raise the bar with respect to supply chain for security for software. And I think this provides us with a unique opportunity to actually consolidate a lot of capabilities that have been built in this in the space of software security, and all for a good cause. So I'm going to pause here. I know we have a few minutes, like 3 minutes left. Any comments or questions, please?
If no one else has any, I'll toss one. What do you think about software bill of materials for insights?
Great question, Steve. So SBOM, as it's called, software bill of materials, just for the people who are unaware of what it is. It is really an enumeration of the sort of, at a high level, the dependencies that a particular piece of software has. Think of it more like a active ingredients list, or almost like a barcode that would tell you what the dependencies are. Recently, I think actually the federal government, I think the Department of Commerce has actually put out a specification for the SBOM, software bill of materials, to invite comments from vendors. But I think it is similar to what you said about the safety board. I think it is a step in the right direction, but I don't know whether it goes far enough. I think it provides a crucial piece in terms of explicating dependencies, doing dependency analysis. But in terms of using that further, for example, to do sort of the root cause analysis that you're talking about in the case of breaches, how to use that capability to make it much more actionable is an area I think that could have interesting applications as we go forward. So I think we turn this back to you, Sharon. Thank you very much, both from Steve and myself, for inviting us to this panel and giving us an opportunity to share with the audience an area of policy which is going to really affect the security industry for the next few years. So thank you.
Thank you both, Steve and JR. I'm not sure if I feel better or worse after that discussion, but I feel more informed. So that was excellent digestion of that executive order. And yeah, maybe we will have a full-time board someday.